In this video, we are going to talk a bit about simple and compound interest and try and find, well, what's the difference between the two, and start to have a look at a little bit of the maths behind the two, just sort of basic intro, I guess. So the biggest thing is this, between simple and compound interest. In simple interest, the principal doesn't change. Now, the principal is the starting amount. Now, it could be for an investment, could be for a loan. The maths is exactly the same, but whatever the starting amount is, that is our principal. So let's look at an example and just see how it works. From previous videos, hopefully you will have seen the simple interest videos, and you'll know that all we do is we take our principal, our starting amount, we multiply it by the interest rate to get the amount of interest. So don't forget though, with an interest rate of say 6%, like in this question, we always convert that to a decimal. So divided by 100, and we're going to use the 0.06. 6% of 8,000 is $480 interest, and if I add that now, my investment, or my loan, is worth 8,480. Now if I go to year 2, after the second year, the principal is still 800. So let's say that 480, I've taken it and I've put it somewhere else. I haven't put it back in the bank. So another 6% is another 480. So now I've got this much money. I've got my 8,000 to start with, plus 2 lots of 480 worth of interest. Okay, and if I follow that right through for 10 years, what I end up with is a value of 12,800. So the original 8,000 and 10 years worth of $480 worth of interest. So that's simple interest all the way through. The principal didn't change. We just took the interest and we put it aside. However, with compound interest, the principal grows because we take the interest and we put it back in to the principal. Let's see what I mean. So the first year is going to look exactly the same as our simple interest year. $8,000 times 6%, $480 interest gives me a balance of that. However, now I take that amount, the 8,480, because I'm going to keep the interest and put it back in to the account. So now my principal goes up to 8,480. So this number and this number are the same. So now when I work out the next year's interest, it's 6% of this amount. And you could see it's bigger than 480. Now it's up to $508.80. So my new balance will be the principal for year 2 plus the interest that I earned in year 2, add them together to give me this figure. And then that flows right through to the next year. This amount becomes my new principal because I've taken this amount of interest and I've put it back into the principal. 6% of that, and you can see year on year, and if I go right through all 10 years, you can see the interest amount continues to grow. Okay, you'll see the principal continues to grow. Okay, and in fact, if you were to look at this, remember the balance from the year before becomes the new principal for the start of the next year. So I can see this amount was the same, right? At the end of year 2, my balance became the principal for the start of year 3, etc., etc., and that flows all the way through for 10 years. Now, at the end of 10 years, you can see in simple interest, I've got 12,800, but with compound interest, I've got much more than that because the interest has been growing as the principal has grown. Here's where we start to look at the maths though for compound interest. So let's think about this. We're gonna create the compound interest formula and we're gonna show you how it's done. You don't need to know this bit. This is just how we get to it. You need to remember the formula though. Going on compound interest, my first year, I had 8,000, I times it by 6%. Well, in fact, what I did was I increased it by 6%. So I multiplied it by 1.06, right? Remember with percentage increases, we changed the 0 to a 1 because we're actually just increasing it. So 8,000 increased by 6% gets me my 8,480. That's this amount here. All so far, so good. What if I did a second year, so I increased it by 6% again? In the third year, I increased it by 6% again. And you'll see after 3 years of 6% increases, right, just each year multiplying it by 1.06, I've got 952813, which is this value here. Okay. Now, I can look at these 3 lots of 1.06, this multiplied by itself 3 times, and write that to the power of 3. So really I've got 8,000 times the 1.06 cubed, because it's times itself 3 times. So that's just cubed. And this is where the magic happens, because let's have a look at what is in this. This amount, the 8,000, was my principal. This amount, the 0.06, was my interest rate. And this number here was the 3 years of the 3 time periods that are multiplied by. So we can take that, and instead of using numbers, we're going to use letters to represent the principal, the rate, and the time period. And here is our compound interest formula. The amount that your money will grow to equals the principal, in brackets, 1 plus the interest rate. So for our example, it was 1.06, so it's 1 plus the 0.06, all to the power of however many time periods it's been compounded for. Okay? A equals the amount, P is the principal, starting amount, R is the interest rate as a decimal, and N was the number of time periods. And that is the compound interest formula. It's a formula we can use to work out how much something will grow to if it's compounding over a certain number of time periods. Let's try this and put in the values for our 10th year. So if we want to, let's see, can we get to this value here, this 14,326? Our principal was 8,000, our rate of interest was 6%, and it was over 10 years, over 10 time periods. If I put those values in to my formula, right, principal, 1 plus the rate, all to the number of time periods, punch that into my calculator, I get 14,326, which is exactly what we got when I was doing it manually, like year by year. Each year I just calculated out the numbers. We don't need to do that. The compound interest formula does it for you. Awesome stuff. Well done.